All right, so as we move on from conductors and insulators, this is one of my favorite things to talk about in science. As we talk about electrical energy, you're going to learn how does the flow of energy travel in a circuit, okay? There's two types of circuits. So if you end up wanting to be interested, you might want to be an electrician when you grow up. Great career path, okay? There's two ways that the flow of energy can travel. So here we see two light bulbs. All the wires are connected to that battery. Okay, the wire comes out the positive end. The flow of energy goes to the negative end. It only has one path to go when you look at this diagram. Because it only has one path for that current to go, it's called a series circuit. Okay, but unfortunately, if one of these light bulbs goes out, they all go out. Okay, so maybe around Christmas when you put up your Christmas lights, you have to figure out what exact light bulb went out and caused the entire circuit to go out. Then you know it's called a series circuit. Okay, another type of circuit, a little bit more complex. It's nice though when you have Christmas lights. If one goes out, the rest of the circuit still works. A parallel circuit is when that flow of energy has more than one pathway for that electricity to flow. If one bulb goes out, the others can remain lit. So if we look here at this diagram, the flow of energy coming out of the positive end can go to this light bulb, then through that negative end of the battery. It can also go to the other light bulb and go around. So it has more than one path versus a series circuit, just one little way that flow of energy can travel. Okay, so here again, series circuit, when these devices are linked in a row, one after another. So we got a light bulb, right in a row. That electricity flows through them together, okay? A circuit then is set up with devices that we call a series circuit. So that flow of energy always comes out the positive end of the battery, only one way to go, goes from one light bulb to another, and the wires go to the negative end of the battery. Series circuit, one pathway to go. One of these bulbs goes out, they all go out, okay? A parallel circuit, when these devices are linked together with separate paths or loops, the current then splits and has independent path to take through each device. We call this a parallel circuit. It has more than one path for that flow of energy to go. What's the difference? Okay, so let's say you have three light bulbs linked together in what we call a series circuit. So right now you're looking at the screen, you see three light bulbs in a row. It's still, even though it has three light bulbs, it still only has one path that this electrical current can flow. So if one of these light bulbs blows, what happens to the other two? Okay, that circuit is no longer closed. The current can not flow through the other bulbs. So guess what? They all go out, okay? So let's say we've got a parallel circuit, okay? Say we have three light bulbs. It's a parallel circuit. I'm letting you know it's parallel circuit because it has more than one path that electrical flow can go. What happens to the other bulbs? So if one of these bulbs, this one that's shaded, goes out, it can still go to this light bulb. It can go to the other light bulb. The other light bulbs still will stay lit. Okay, so what you've gathered, a series circuit has one pathway for that flow of energy to go. And if one light bulb goes out, they all go out. In a parallel circuit, it has more than one path, okay, for that electrical energy to flow. And if one light bulb goes out, guess what? They still work, okay? So series versus parallel circuits, okay? And then we'll meet back up again here to talk more in depth about circuits and just kind of review that series and parallel circuit. Then we will continue here shortly.